Managing SQL Server. In this nugget, we're going to talk about a few miscellaneous management things that you're going to have to worry about, such as managing resources on SQL Server, implementing a policy-based management framework, worrying about data compression, and some techniques that SQL Server offers to automate some administrative tasks. Let's start with some of the basic areas you have for managing performance of a particular instance. Now, these are all configured as properties of the instance. So we're going to right-click the instance, select Properties. First up is Memory. You can allocate a minimum amount of server memory to SQL Server, or a maximum. It defaults to a minimum of 0 and a maximum of however much you have on the server. On 32-bit computers that have addressing Windows extensions, you can use AW, addressing Windows extensions, to allocate memory beyond the normal barriers. Now, on processors, you can determine what kind of processor affinity SQL Server has. This computer only has one processor. If you have multiple processors, then you can decide which ones SQL will run on. And finally, on the Connections tab, you can set the maximum number of user connections. 0 is unlimited. And you can use the Query Governor to prevent long-running queries. Again, this is an instance-wide configuration option. If you turn this on, any query will not be allowed to run longer than that many seconds. Once it runs that many seconds, the server just kills the query automatically. So you need to adjust it according to what you know your production needs are going to be. Now, SQL Server 2008 introduces something called the Resource Governor, which is a little bit more granular than the Query Governor. Again, the Query Governor is instance-wide and only applies to queries. Here's how the Resource Governor is built. You start by configuring resource pools. And each resource pool might be allocated a certain percentage of CPU time or memory or some other set of resource. So that's the pool of resources. Then you create workload groups, and workload groups are executed by resource pools. Then you have a set of classification rules. These categorize the incoming workload, different types of queries, different types of operations, and it places each into a specific workload group. So basically what you can do is say certain types of operations are going to be executed by certain resource pools. Low priority operations, as you determine, will be executed by resource pools that have relatively fewer resources than a resource pool which is intended to execute high priority operations. So let's take a look at how we can actually set some of those things up. So under Management, here's the Resource Governor, and the little down arrow icon tells you that this is currently disabled. Now, there are two system resource pools by default. The internal pool is where all of SQL Server's own processing occurs, and the default pool, by default, is where everything else goes. And you've also got in here, if we take a look at the properties, you've also got workload groups, and the default one is where everything goes that hasn't been classified to go somewhere else. So what we're going to do is enable the Resource Governor, and we can create a new resource pool. We'll call this Critical, and we'll give it a minimum CPU percentage of 10%, and then we can also specify a minimum memory of, let's say, at least 10% of the server's memory. So now we can create a workload group for that resource pool. We can say group 1 is a medium resource. We've got different things that we can configure on that. We can create as many of these as we want to. And we would select a classifier function that tells SQL Server what workload goes into this group. Now, writing classifier functions is a little out of scope for this particular series of nuggets. It's definitely something more for a database developer. But basically, you create a function, certain parameters are passed into the function to describe the action that SQL Server is trying to execute, and the classifier function tells SQL Server whether or not that belongs in this workload group that we've just created. So you set up all your classifier functions, you register them with the Resource Governor, which is covered in the books online if you've got a database developer who needs to know how to do it. You create your resource pools, you set up all of their different parameters, and then you set up the workload groups that go with it. So the trick here is when I click OK, Ooh, we got an alter failed for the resource governor. Well, here's the trick. This is running the standard edition of SQL Server, and the resource governor, while present and configurable, you'll notice that I was able to create my critical resource pool and create the workload groups within it. You can't actually enable the resource governor in the standard edition of SQL Server. So that's something to kind of keep in the back of your head. But that's basically how it works, and it's how everything flows together, and that's how you would go in and administer it through this graphical user interface. Then the next area of SQL Server management is called policy-based management. And we've touched on this before, but let's just sort of go through it again real quick. We start with different facets of the system that we can control. Database maintenance, things like this. If we look at the properties of this, we can see all the policies that are built to use this. Currently there are none. And we can look at any conditions that have been built on this particular facet of SQL Server. So once we've looked at facets, we can go under conditions. Now let's create a new condition. So we're going to select the facet that we want to go from. Let's say data file. And then we can create different conditions. We'll select a field, let's say available space, less than 10, and growth type not equal to, or let's say growth type equal to none. So what we're saying here is this a condition, check for databases running out of room. This is going to apply to the data file aspect of the server, and the condition is going to return true if the database's available space is less than 10 and the growth type is equal to none. That means we're running out of space and the database file isn't set to grow automatically. So we'll click OK to create that condition. Check for databases running out of room. So that's a condition we've created. Now we can create a policy that utilizes that condition. We're going to check the condition, check for database running out of room. So the name of this policy is make sure databases have room. We're going to target this to every file in every file group in every database, or we can just limit it down to certain databases that we want. We can apply another condition, but we'll leave it on every. And we can choose to evaluate this on demand or on a schedule, and I'm going to choose to evaluate this on a new schedule. We're going to call it nightly, and it is going to be done on a daily basis every day at 1 a.m. So, and I'm only going to restrict this to, and I can choose to restrict it to particular servers, but we're just going to leave it run as is. Let's enable this policy. Now once policies are enabled, you'll see that these two are not enabled. They've got the little down arrow there. I could choose to enable those just by right clicking, or I can evaluate them on demand. Go ahead and evaluate. Here's what happens. Well, let's select a policy to see detailed results. Looks like we had a problem with a particular thing failing this policy. So that's going to tell us that we've got a database that doesn't have auto shrink turned on. And by setting these policy-based things up, you can ensure that certain configuration parameters or certain conditions are being met constantly without having to go in and manually check. You can just walk through, have it check on a schedule, have it notify you automatically if a policy isn't met. And the policies are really intended to match your top-level business policies. So that's the policy-based management framework within SQL Server. Our next management topic is compression, which is available only in the Enterprise edition of SQL Server 2008. Now, SQL Server basically supports two types of encryption: row-level encryption and page-level encryption. Keep in mind that in SQL Server, multiple rows of data can potentially be stored on a single page. So row-level compression applies the compression before the data is written to the page. Page-level compression compresses everything that's on the page. So there's a nice table. If you look up row compression implementation, there's a great table that tells you how various data types are affected by compression. And this is important because if you're looking at a row that has several data types that are not affected by compression, small date time, date, time, then you may not actually get much benefit from row compression. So this is definitely something as a consideration. If you're saying, for example, that, well, most of our data is being stored in varchars, well, looky here. Row-level compression doesn't really affect varchars storage, so row-level compression isn't going to do you much good. It's worth reviewing this. I mean, varchar and nvarchar are two very common types, so if the majority of your row consists of that, then row-level compression is probably not going to do you much good. Now, the other type of compression that I mentioned is page-level compression. That works slightly differently. That actually compresses all the data that's written to the page, and it also compresses the page headers. This help topic has got a nice little diagram here. These are the individual rows of data in the page header prior to compression, and then they all get compressed in the page header. So you actually save a lot of room. One of the neat things about page compression is that when you enable page compression on a table for the first time, you have to completely rebuild every page of data in the table. So if you've got a large table with hundreds of thousands of rows of data in it, and you decide you're going to turn on compression for that table, you should expect to wait a little bit while SQL Server rebuilds all of those data pages and compresses all of that data for the first time. So that's definitely something you need to plan for, and probably not something you want to do in the middle of the workday. Now, to actually enable compression on a table, you're going to need to issue a SQL Server command, such as alter table, provide the table name, rebuild the partition, specify the table partition you want to rebuild, usually one, with data compression, and then you'll specify your data compression option. In this SQL Server topic, creating compressed tables and indexes kind of walks you through the whole thing. Here's the deal. Compression is something that you tend to do once, ideally when you create the table for the first time before there's a lot of data in it, and then you leave it alone. It's not worth your while to memorize this syntax. Look it up. That's why I wanted to show you where to find that. Just look up creating compressed tables and indexes in the Books Online Index. Now, if you are using compression with replication, there are some concerns that this topic will also sort of cover. We haven't talked about replication yet, but if you are going to be doing replication with a table, keep in mind that compression does affect how that replication works. So it's worth, sort of perusing this table for a little bit, spending some time. Compression also does have some effects on other SQL Server components, like bulk import and export. It does not affect backup and restore, and that's definitely convenient. It also doesn't affect log shipping. So you just kind of be aware of that. Now, you also can do this, enable data compression in the graphical user interface. Just in that Object Explorer, you would right-click either a table, right-click an index, or right-click an indexed view, point to the storage option, and then select Compress. Here's the thing, though. Let's go into a database, and we'll go to a particular table, and we'll right-click it, and I don't see a storage option. Again, only available on the enterprise version of SQL Server, and this here is standard. That's definitely kind of almost a trick question to keep in the back of your mind. You're not going to see that option if you're not running on the enterprise edition of SQL Server. Lastly, let's talk about some of the options you have for automating SQL Server administration. Some of these we've talked about before, so we won't go into more detail here. And the big one of those is SQL Server Agent. It's basically a task scheduler that lives within SQL Server itself and can run all types of tasks for you. There's also event notification. It's also sort of tied to SQL Server Agent, and it's designed to watch for certain types of events that are occurring in SQL Server and then notify a pre-designated operator when those events happen. You've also got data definition language, or DDL triggers, and those can be used to automate actions and have certain things occur whenever the SQL Server schema is modified. So if somebody creates a new view or deletes a table, you might have it log an audit trail entry or send an email to notify someone or something else. So it's another form of automation. And probably the last one is Windows PowerShell, which is a new feature that SQL Server 2008 supports. And there are a couple of caveats to this. Real quick, let me bop back to SQL Server Management Studio here. And you'll notice that when I right-click, nearly anything, I've got this option to start PowerShell. So let's start PowerShell up. Notice that this is coming out of Program Files, Microsoft SQL Server, and it's running something called SQLPS.exe. So if you're familiar with Windows PowerShell, you need to be aware of a few caveats regarding the SQL Server implementation of it. To start with, when you launch Start PowerShell from within SQL Server, what you're actually starting is the SQL Server mini shell. This is not a full implementation of Windows PowerShell. It consists of the PowerShell core, in other words, everything that makes up PowerShell itself, plus a snap-in that gives you a few SQL Server commandlets and a SQL Server provider that exposes SQL Server to you as a disk drive. A trick with this is that you cannot add no other snap-ins. You get no more snap-ins. So it's kind of locked down to just run the SQL Server stuff. Now that means if you need to automate a process by writing a PowerShell script that involves SQL Server and maybe manipulating some files in the file system, those are all things that the PowerShell core knows how to do, then you're fine. If, however, you wanted to automate a process that maybe created a new Active Directory user, did something with a SQL Server database, manipulated a file, and then maybe touched something in Exchange Server, you cannot do that in the SQL Server mini shell. Unfortunately, the mini shell doesn't allow you to add any functionality. Now, here's kind of where that comes into play too. Let's go into SQL Server Agent here, and I'm going to create a new job. And let's just go right down and create a new job step. And you'll notice that one of the step types is to run a PowerShell script. Anything that happens in here is going to be run through the SQL Server mini shell. So it only has access to those things that are in SQL Server and in the core of Windows PowerShell. So just be aware of that restriction. Now the SQL Server mini shell is pretty powerful. For example, I'm going to make sure that window has the focus there and change up a directory. And then if I get a dir, I can see all the databases. I'm going to cd my database and then get a directory. I'll cd into the tables folder, get a directory. There's the my table item. So, this is really just treating SQL Server as a kind of disk drive. In fact, you can see here on the path that I'm in the SQL Server drive. I could certainly change to my C drive as well. So you kind of treat SQL Server as a file system from that perspective. Now, writing PowerShell scripts is definitely out of scope for this series of nuggets. You can definitely pick up a series of nuggets on working with Windows PowerShell, and most of what you're going to learn in there is going to apply to this SQL Server mini shell, with the exception that you cannot work with additional snap-ins. In fact, if I run get ps snap-in, the command that will list all the loaded snap-ins, it doesn't work. That has been removed from this mini shell because the mini shell is a self-contained environment. Here's a little trick though. All of the SQL Server functionality in that mini shell do live in snap-ins. It's just that mini shell, which is what's made available to you from within SQL Server Management Studio, that mini shell itself is restricted. There's nothing stopping us from installing the full Windows PowerShell, opening it up here, and let's take a look at the get ps snap-in command. So those are all the core PowerShell snap-ins. Now let's look at the other ones that are registered on this system. And you'll see that the SQL Server commandlets and the SQL Server provider are in regular snap-ins. Well, I wonder if we can add those here. Add snap-in SQL Server commandlet snap-in 10.0. And now let's add the SQL Server provider snap-in 100. So let's see if we can now change to the SQL Server drive and get a directory. We can. So you can have PowerShell scripts that impact Exchange and SQL Server and Active Directory and anything else you've got a snap-in for, but you have to do it within the full PowerShell, not within the SQL Server mini shell. So let's take a look at the commandlets. Get command only from the ps snap-in SQL Server commandlet snap-in 100. So the SQL Server snap-in only provides 2 commandlets for you. Invoke SQL command is the one that's going to provide the most functionality to you. What that does is it lets you fire off any T-SQL query that you want. Because SQL Server itself is already fully scriptable through the T-SQL language, you can really do anything in SQL Server that you want to do in PowerShell just by invoking SQL commands. The other one is invoke policy evaluation, and that allows you to take one of those policies that we set up a little earlier, force it to evaluate, and then collect the results of that. Let's see if we've got some help on invoke policy evaluation. And we do. It says that this evaluates one or more SQL Server policy-based management policies against a target instance. So the results of that then come out. So what you could do is go into SQL Server, into Management Studio, set up a bunch of policies, and then create yourself a PowerShell script that invokes the evaluation of those policies, takes the results, maybe converts it to an HTML table using the convert to HTML command within PowerShell. All of that can be done in the mini shell. These two commandlets are available in the SQL Server mini shell, as well as all the core PowerShell commandlets like export CSV, convert to HTML, export CLI XML, all those different types of commands. So Windows PowerShell does offer a lot of opportunity for a very different type of management automation in SQL Server. Just keep in mind the limitations of the SQL Server mini shell, and keep in mind that you can always go out to the full Windows PowerShell, add the SQL Server snap-ins, and really do pretty much anything you want. In this nugget, we've done sort of a wrap-up of management tasks that you've got to worry about, such as managing resources, either using the Query Governor or the Resource Governor if you're on Enterprise, policy-based management, ways of setting up top-level management policies, and then having SQL Server automatically evaluate your compliance with those policies and alerting you to anything that's out of compliance so that you can deal with it. We talked about some of the concerns of data compression, which is also only available on Enterprise, and we looked at some of the techniques you have for automating SQL Server administration, including SQL Server PowerShell, SQL Server Agent, event notifications, and DDL triggers. I hope this has been informative for you, and I'd like to thank you for viewing.